Part number 1. Linear functions as mathematical model. When you get into a cab, there is an initial fixed rate of $8 plus the additional rate per kilometer of $4.5. Determine the specific equation that can relate the payment fee with the kilometers traveled and make a graph to the mark function. How much would you pay for 25 kilometers journey, and if you pay $48.5, how many kilometers did you travel? To solve the problem, we have to identify the data that we have. We know that the initial fixed rate is $8, and per each kilometer we add $4.5. We are going to use the next formula. Y is equal to ax plus c, where y is equal to the total cost, x is equal to the extra kilometers, a is equal to the cost per kilometers, and c is the initial fixed rate. Now we graphic. Now we want to know the cost per 25 kilometers. We have to substitute the values, and we have y is equal to 4.5x plus a, and then we multiply and substitute the values, and finally we have that y is equal to 120.5, and that is the cost per 25 kilometers. Now we want to know if we pay $48.5, how many kilometers we did travel. We substitute the values, and then we clear the x. X is equal to 48.5 less 8 divided by 4.5. X is equal to 9, and 9 is the kilometers that we travel per $48.5. Problem number 2. The owner of a hamburger place pays weekly $1,175 to produce 35 hamburgers, while producing 60 hamburgers costs him $1,550. If each hamburger is 40, determine the following. A. The specific equation that can relate the expenses with the number of hamburgers made. B. The specific equation that can relate the income regarding the number of hamburgers sold. If he sold 35 hamburgers, he won $250. If he sold 60 hamburgers, he won $850. We substitute the values, and now we have y less 225 divided by x less 35 is equal to 25. We substitute, and finally we already know that 25x less 650 is equal of the equation. C. The quantities of hamburgers that need to be made and sold in an order that the owners won't gain or lose money. Balance point. We're gonna use our formula y is equal to 25x less 650. We substitute the values, and now we know that x is equal to 26, that are the hamburgers that they have to make to don't lose or win money. D. The utility function equation. E. The profit if they produce and sell 45 hamburgers. We substitute the values with our formula, and finally we know that y is equal to 455. That is the profit if they produce and sell 45 hamburgers. F. How many hamburgers are supposed to be produced and sold weekly to have a profit of 1,100? We substitute the values with our formula, and finally x is equal to 15, and finally x is equal to 70, that are the hamburgers that they have to produce. Problem number 3. Study which are the temperatures in Celsius and Fahrenheit degrees or freezing and boiling water. Once you have this, and based in the previous information, determine the following. A. The equation that associates the Fahrenheit degrees in accordance to the Celsius. Now we have two formulas. B. Which is the equivalent of 20 degrees Celsius to Fahrenheit. Then we substitute the values, and the answer is 68 Fahrenheit. C. Which is the equivalent of 140 Fahrenheit degrees to Celsius. We substitute the formula, and the answer is 63 Celsius degrees.
In the part 2, the first problem tells you to use the equation of the first problem in the part 1. The equation is 4.5x plus a, where x represents the numbers of kilometers traveled. Question 8 tells you how many kilometers we must travel so that the total is less than 100. In this case, the equation will be 4.5x plus a less than 100, and we will only continue solving the x to obtain the value of the kilometers. The result is 20.4. This refers to the cap must travel less than 20.4 kilometers so that the total is less than 100. The question B tells you how many kilometers we must be traveled so that the total is greater than 150. For this, we will use the same equation as the problem A, only that this will be 4.5x plus a greater than 150, and we will continue solving the x to get the number of kilometers. The result is 31.5. This means that the number of kilometers must be greater than 31.5 for the total to be greater than 150. The problem 2 tells you to use the equation of problem 2 of part 1. The problem tells you how many hamburgers need to be sold so that the total will less than 2,500. To solve it, we must use the equation 25x minus 650 less than 2,500, and we would only continue solving the x to obtain the value of the hamburgers. The result is 126. This means that less than 126 hamburgers are needed to have a total of less than 2,500. The problem 3 tells you to use the equation of the third problem of part 1. In this problem, that tells you how many degrees Celsius should be the temperature to be greater than or equal to 104 degrees Fahrenheit. To solve this, we will use the equation 1.8x plus 32 is equal to or greater than 104, where x is the number of degrees Celsius, and we will continue solving the x to obtain that number. The result is 40. This means that the number of degrees Celsius must be greater than equal to 40.
So now we're going to do the part 3, quadratic functions as mathematical models. And now we're going to answer the next questions. So now we're going to do the first question. What is the name of the following quadratic function graph? And the answer is parable. In letter B says, what is the name of the only point in the graph when there is only a value of x for a given j value? And the answer is vertex of the parabola. Now, letter C says, where does the graph opens to if A is positive? The answer is it opens upward. Then, in this case, does the graph have a maximum or minimum value? We can say it has a minimum value. Now, in letter D, where does the graph opens to if A is negative? The graph opens downward. Now, in this case, does the graph have a maximum or minimum value? It has a maximum value. Now, letter E says, which is a formula to determine the value of x where it has the maximum or minimum value of the quadratic function. H is equal to negative b above 2a. Now, f. How can the corresponding maximum or minimum value can be calculated? K equals to negative d above 4a.
So now we're gonna do the exercise number 1, and it says, calculate the height an object can reach when it is thrown in an upward vertical shot with an initial speed of 30 meters per second from a building of a 13.5 meters height. Based in this formula, determine the following questions. The letter A says the time it takes an object to reach its maximum height. So time is equal to final speed minus initial speed above acceleration. So now we're gonna substitute the values. 0 minus 30 above negative 9.81, and the result is time is equal to 3.05 seconds. Now we're gonna calculate the maximum height an object can reach. Y is equal to initial speed per time plus acceleration per time square above 2. And now we're gonna do the same as before, and we're gonna substitute the values. So the result is y is equal to 45.88. Now we're gonna do the exercise number 2. If there are 120 meters of a terrain to fence in a rectangular way, we have to calculate the letter A. Which are the measurements of the land for the area to be at its maximum capacity? So we're gonna do the next equation. 2x
plus 2y is equal to 120. So 2y is equal to 120 minus 2x. Y is equal to 120 minus 2x above 2. And the answer is y is equal to 60 minus x squared. The equation for the area is equal to x per y, and now we're gonna substitute the values. A is equal to x per 60 minus x squared, and the answer is 60x minus x squared. And then we're gonna use this formula. H is equal to minus b above 2a. H is equal to minus 60 above minus 2. And the answer is H is equal to 30. So H is equal to x, that is equal to 30. And then we're gonna substitute the values from the first equation that we used before. So 60 plus 2y is equal to 120. 2y is equal to 120 minus 60. So y is equal to 60 above 2, and the answer is y is equal to 30. So now we're gonna do the letter B, which is the corresponding maximum area. In this case, we are just gonna substitute the formula for the area. Area is equal to x per y, that is 30 per 20. So the area is 900 meters square.